Hi, I'm Alex Hutchins, and this is my Challenge Assignment 1 demo for ECE461, Embedded System Design at NC State University. The goal of this assignment is to develop a system that will verify a successful erase and write of 128 kilobytes of flash main memory once every minute. A Watchdog timer is to be configured to reset the system every 1 second unless cleared by software. However, a timeout should not occur in an ideal system. For the purpose of this assignment, a user can force a Watchdog timeout by pressing button switch 1. This system is implemented on an MSP432 launchpad, and it was developed using Code Composer Studio. I will demonstrate the user interface in real time. I will then demonstrate loading the code onto the board and using the debugger to verify that the system is erasing then writing to flash main memory. Along the way, I will be explaining my code. Let's start by powering the device. First, I will demonstrate forcing the Watchdog timeout. Notice when I press switch 1, LED 1 lights up for red for 1 second. As I press it again, it forces yet another timeout. When I hold the button, it continuously times out. Now, once I release the button, the program will run uninterrupted as intended. LED 2 will light up green for 1 second and a minute from reset. Remember, this indicates that 128 kilobytes of main memory have been erased and written to. Now that the green LED has toggled, flash memory has been erased and written to. I will now demonstrate using the debugger. I will now go through and explain my code using Code Composer Studio. I will also demonstrate the system using the built-in debugger. First, I would like to start off by reminding that I will be writing to memory bank 1 of flash memory, which is 128 kilobytes, and it starts at this address. So, first, I will load the code onto the board. Now that the code is loaded onto the board, I will set 2 breakpoints, which will indicate that the bank 1 memory has been erased and that it has also been written to. And as pointed out in the user guide, this is the starting address for bank 1. As you see here, it is completely written with ones. This is indicative of being unwritten or completely erased. So now I will let the code run until it reaches the first breakpoint, and I will be explaining my code while it runs. So here are my global variables. There's 3: program status, which is initialized to running, switch status, which is initialized to unpressed, and a half-second counter, which is initialized to 0. Here's the main function, and it begins with turning off the Watchdog timer, initiating the ports, initiating timer A0, enabling interrupts, enabling timer A0 interrupt on the NVIC, enabling port 1 interrupt for the switch on NVIC, confirming the timeout by toggling the red LED for 1 second, initiating the Watchdog timer, resetting the half-second counter to 0, and here's the round-robin operating system while loop. If the program status isn't timed out, then it will continue to enter the next conditional statement, checking if a minute has passed. And it's actually 57 seconds because there's 3 seconds that occurs for the flash. Next, bank 1 is unlocked because there's a write erase protection. Next, the flash memory for bank 1 is erased. Then flash is written to. The bank 1 is then locked so that it can't be accessed. And then there's the flash confirmation, which toggles the green LED for 1 second to confirm that the flash has occurred, and then the half-second counter is reset again. So the breakpoint just occurred after erasing the flash memory, which it was already initialized to being erased by showing all ones or hex F. So next I will run it again, and you will see that flash has been the flash bank 1 has been written to. It will So let me disable that breakpoint and then run it again. And now you can see that flash has been written to, and the end address for bank 1 is the following. And you can see that all of bank 1 has been written to. So I will then run it again, and just after erasing the flash, the breakpoint will then stop the program again. Next, I will be going through the Watchdog folder or file, and this Watchdog timer interrupt service routine is not used. The function Watchdog timer off is used, and it just writes to the Watchdog timer control register, setting the password and holding it. Next is Watchdog timer initialize, which configures the Watchdog using the B clock as the clock source, clearing the Watchdog counter and setting the Watchdog interval to 32K, or 2 to the 15 ticks, which in this case is 1 second. Here is timeout confirm. Okay, so the breakpoint just met again, and you can see that flash memory has been erased. It is now showing all F's, or indicating 1s, being that it has been erased. So I will now set a breakpoint to indicate that a reset has occurred once I press switch 1. So I will now let this run, and I will continue explaining the code. So here I forgot to delete this initialization of a variable, and Code Composer Studio suggests using a timer module instead of an empty loop. Now, I could have used a for loop that just counts and just timing 1 second using the amount of time for a certain amount of clock cycles. Instead, I chose to use a while loop and the combination of a 1 second timer, or a half-second timer. So for the timeout confirm, the half-second counter is cleared. Port 1 pin 0 is turned on, which turns on the red LED, and then it enters a while loop waiting for 1 second to occur, and once it has, it turns off the red LED. Next is the ports file, and here's ports init, which initializes the ports by calling port 1 init and port 2 init. Port 1 init does exactly as it sounds, initializes port 1, starting with pin 0, which is the red LED. It sets pin 0 to output for red LED. It then sets the output to off for the red LED. Next is switch 1, which is at pin 1. It sets the pin to input for switch 1, enables the pull resistor for switch 1. Then this indicates that it is a pull-up resistor. This enables interrupt for switch 1. This enables interrupt edge select for switch 1. And this clears the interrupt flag for switch 1. Next is port 2 init, which is for the green LED at pin 1 of port 2. So first the direction is set by setting it to output. Next, the output is set to off. Here's the port 1 ISR, which is used for the button switch 1. Here's a conditional statement checking to see if switch 1 interrupt flag has been set. If it has, then it clears the switch 1 interrupt flag. Switch status is then changed to pressed, and then the half-second counter is then reset to 0. Next is the timer A file. Timer A0 is initialized by calling timer A0 init. First, TACCR0 interrupt is enabled, which is timer A capture compare register 0. Next, the timing interval for timer A0 capture compare register 0 is set. Then the control register for timer A0 is initialized by using SM clock, predivide 8, and continuous mode. Next, the clock is then divided by 8 again. Altogether, this makes the timer a half-second timer. Here's the timer A00 interrupt service routine. First, the capture compared interrupt flag is cleared. The offset is added, and then it enters a conditional statement, checking to see if the switch has been pressed or if the switch is being held down. If it has, and it then enters a debounce, and then once it has been debounced, then the program status is changed to timeout. If this hasn't occurred, then the Watchdog timer counter is then reset, and then after the conditional statements, the half-second counter is incremented. Next is the flash file. This is the function to write to flash main memory bank 1. here is a pointer for the beginning of flash, or here's a pointer for flashbank 1. Here's an index for the loop. The pointer to flashbank 1 is initialized to, or is set to, the first address. This line sets the automatic post verify. This line sets the automatic pre-verify. Together, these allow to automatically verify that the flash has been written to, can be, and was written to. This sets to immediate write mode, and this begins this enables flash writing. Next is a for loop which traverses through all of bank 1 addresses. This is a wait, a conditional loop waiting for the status to write. Once it is all right to write to flash memory, the counter for the for loop is written to the given address. Next, the flash pointer is incremented to the next address. Next is the erase flash function. The control register for erase is set to mass erase mode, which will erase all of flash memory except for the parts of the memory that are protected. This line initiates the mass erase. This sets the read mode to erase verify because there is no automatic verification for erase. Next is a conditional loop waiting for erase to occur. This conditional statement, if statement, checks for an erase. The next conditional if statement checks for the erase verification, and if the verification has occurred, then the erase status is then cleared, and then the while loop breaks, ending the function. Next is the flash confirm, which is like the timeout confirmation. First, the half-second counter is reset. The green LED is turned on. Then it enters a wait loop, waiting for 1 second to occur, and then the green LED is then turned off. Here is the header file showing all the macros used. First is the NVIC macros. These are to initialize the interrupts for the NVIC. Next is the main macros, which shows the program status for running, which is 0. Next is the flash macros, flashbank 1 start, flashbank 1 end, which isn't used, flashbank unlock, flashbank lock, which is used to enable and disable the flashbank write erase protection. Next is the Watchdog micro, which is timeout. Timer A macros, which is the timer A0 capture compare register 0 interval, which assumes that the 8 megahertz clock and then dividing by 8, dividing by 4, and dividing by 2 hertz. Next is 1 second, which is 2 half seconds. Next is the minute, but which is actually the 56 seconds, I believe, and then the 4 seconds for the flash to write. Next is the count reset, and then port macros for the button unpressed and pressed. Here's the function header file, which has all the declarations for all the functions. Here's the startup file for the NVIC. Here are the interrupt service routines are declared, and here's the actual NVIC. And that is all for the code. And I will go back through and I will force a Watchdog timer timeout. And it has occurred, and flash memory was written to because it hasn't yet been erased, and so here it shows that it's been flash has been written.